In this video, we're going to talk about the slope-intercept form of a line. To kind of get our minds back in gear though, let's review how we, in the past, have worked with graphing lines. Alright, let's say we're going to graph the line 2x minus 3y equal to 6. Now when we graphed these in the past, I've said let's go ahead and solve it for y to get things basically in function form so that it's a function of x. So to solve it for y, we would start by subtracting the 2x from both sides. That gives us negative 3y equals to negative 2x plus 6. And you could write that as 6 minus 2x as well. It doesn't matter. Then to get y by itself, we need to divide by negative 3, but what we do to one side, we have to do to the other side. Now on the left, we just get a y. On the right, we need to be sure to distribute the 3 to both of the terms in the numerator. That gives us 2/3 x minus 2. So now we have it solved for y. What we've done in the past then is we did an xy table. And I said that 0 is always a good option because when we plug 0 in for that, basically the 0 times the 2/3 is 0, so that fully simplifies to negative 2. So that's why we like zeros. It just makes things disappear. So we have that. And that's for 0. One of the things we've also talked about is that to find the y-intercept, we plug a 0 in for x. So what we found just now is the y-intercept, and if I plot it, sure enough, it's going to be on the y-axis. Okay? But if we look back here to the equation, the original equation before we plugged anything into it, we could kind of already see that negative 2, because when we plug the 0 in, it zeroes out the x piece, and so the y coordinate of the y-intercept is just that value that isn't being multiplied by x. So we could see that staring us in the face, and I'm sure you guys have gotten used to being able to do that without showing the work. Now, so we're going to put that on the back burner, and we're going to generate some other points to be able to graph this line. For our other points, we talked about choosing x values wisely, and in this case, we want to choose an x value so that when we multiply it by 2/3, it's going to cancel out the fraction. It's going to reduce with that denominator of 3, and therefore we don't have to work with fractions. So we're just going to choose a one wisely. And so in this case, a wise choice would be to choose an x of 3, because that 3 will cancel with the denominator. So when we plug that in, what we see is 2/3 times x. The 3's will cancel, leaving us with just 2. And so we have y equals 2 minus 2, or y equals 0. So our order pair is then 3, 0. We can go ahead and plot that there. Okay? Now we're going to do one more of those that cancel with the denominator. The next number that would cancel with the denominator, if we continue in the positive land, would be a 6. Because 6 reduces with 3 evenly. So we'll go ahead and plug in that for an x value. Alright, plugging 6 in, then the 6 and the 3, those are going to reduce to a 2. And I'll end up multiplying these two 2's together, and that'll give me a 4. So we have y equals 4 minus 2, or y equals 2. Now I'll go ahead and plot that point as well over here on the graph. Okay, so now we have enough points. We can draw in our line. Just sketch that in, go past our points a ways and put arrows. But I want to talk a little bit about the pattern that is occurring as we choose things that reduce with the fraction that's in front of the x. So basically, to get things to reduce with the fractions, we're increasing our x's in increments of 3. Alright, and we can see that on the graph because we're stepping over each time by 3 more. Now, over the whole distance, that was a 6. That's where the 6 came from. But I'm wanting you to look at the incremental steps. The incremental steps are we're doing steps of 3. The next number up that would reduce with our fraction would be a 9, and that would be another step of 3. Or if we went in the other direction into the negative numbers, it would be a negative 3. Still incremental steps of 3. So for each time to get something to reduce with that fraction, we're going up by steps of 3. Now if we look at what's happening on the y side, we're having an increase of 2 each time we go up. Okay, so again you can see that on the graph. To get from one point to the next, basically we've added 2. To get from this point to the next point, we're adding 2. So we're doing incremental steps of 2. And hopefully that makes sense, because the first time we did it, let me put that back up. So when we did x equal to 3 here in my middle column I've created here, the 3's just canceled. These two 3's just canceled, and that left the 2. And so that's that step of 2 that we got for the first one. Now when we did x equals 6, the 6 and the 3 didn't cancel, they reduced to a 2. And then we had to multiply that by 2, which gave us another step of 2. We'd already gone one step of 2, and then we doubled that distance and for a total of 4. And so you can see that there's a pattern happening here. Sometimes when we're doing the math, we get so lost in the computation and punching stuff out on our calculator, we don't step back to see what pattern's happening here. But when we step back here, we can see our x's are always going up by 3 because we're choosing them that way so they cancel with the denominator. And then as a result of that choice, our y's are going up by 2. It is not coincidental that that is the number that's in front of x. Because remember, why are we choosing those x values? So that because of the denominator there. And then they're going up by incremental steps of 2 because of the numerator there. So we choose the x as part of the canceling with the denominator, and so that translates into how much we're going to move the x by. But once we make that choice, it also determines how much the y will change as well. This idea is called the slope of a line, or the steepness of a line, because how much you change in one direction and the other direction is going to turn into how steep the line is. If I have a line, let's say I have this point, and I just go over 1 and I go up 6, that line is going to be far steeper than the line we have been working with. So how far over and up you go to get from one point on the graph to another point on the graph determines this steepness. And we like the word slope in math for lines, and so that steepness is determined by the slope, and we can read that straight out of the equation. When it's solved for y, it's going to be given by that fraction that's in front of x. So let me clear out some of the stuff from this example and kind of re-emphasize what it is that we've seen here, what patterns we've seen here. Okay, so going back to the beginning, the first thing we saw was that we could tell what the y-intercept was by looking at the number that being multiplied by x, and that's going to be the y-coordinate. So the y-intercept is the 0 for x that we were using to get the y-intercept, and then whatever number is not be multiplied by x. And this is only when the equation is already solved for y. These patterns won't work until you solve it for y. And then this thing that we're talking about now, S-L-O-P-E, sometimes I say slopey, that's going to be 2/3. And that number tells us how the x's are changing in increments of how the y is changing, and that translates into the steepness of the line. How much the x will change for how much the y will change. Sometimes it's said the other way around. How much the y's are changing for each change of the x's. Actually, usually it's said the other way around. So generically speaking, We usually write this as y equals mx plus b. Some textbooks you'll see it written as y equals b plus mx. It doesn't matter which order that's written in. But what we know now is when the equation is solved for y. So when the equation is solved for y, we can determine the y-intercept as 0, b, or whatever that number is that is not being multiplied by x. And we can determine the slope as whatever number is in front of x, and that's going to determine how steep the line appears on the graph. Sometimes slope is called the rate of change because it really is a ratio of how fast the y's are changing for how fast the x's are changing. And once we solve for y, we can just pick that information out of there. And it allows us to do some interpretations on the behavior when we start doing modeling with linear equations. But first, before we get to that, let's just do an example where we can see how we can use this information to graph a line instead of just generating ordered pairs. Alright, so we are going to determine the slope and the y-intercept and use them to graph the line for y equals 2x minus 5. Now this one's already solved for y, so I can go straight to it. The slope is the number that's being multiplied by x, and in this case that's a 2, and the y-intercept is the number that's not being multiplied by x. Well, that's the y-coordinate, so it's 0, negative 5 is the y-intercept. You want to start in terms of graphing by plotting the y-intercept because it's the point. You really only put points on the graph. The slope tells us a relationship between the points, but it is not itself a point. It's just directions on getting from one point to another. So the y-intercept's an actual point. We start by putting that on the graph. Now this slope's a little different than the one we saw before, because the one we saw before was a fraction. But remember, we can always make our whole numbers fractions as having a denominator of 1. So this means for every increase of 1 in the x value, we're going to increase 2 in the y value. So on my graph, I'm going to try to highlight this by using a green, but you wouldn't actually do this part. So we're going to go over 1 in the x value and go over 2 in the y, or up 2 in the y value. So we go right 1 in the x value and up 2, we put another point. And we can just repeat that process. So stair step 1 in the x value, 2 in the y value, and put a point. So the green isn't the actual graph. That's just how we're using the slope to get to the points. It's the red that's the actual graph. And once you decide you've stair stepped enough, you can connect the dots. I'll go ahead and erase the green because that was just our aid there. And there you have it. That's our line. So you just use the y-intercept. That gives you a starting point, and then you can do your change from there by reading off from the slope how much the x's are changing for how much the y's are changing. Let's do another one of these. Alright, this time let's look at graphing the line y equals negative 3/2 x plus 3. So first we have to determine our slope and y-intercept. So our well, I'm doing it out of order, but I guess that's fine. Our y-intercept is going to be 0, 3, and our slope is going to be a negative 3/2. So hopefully you're catching on to where I'm doing those. Okay, now for graphing that, we can start by putting the y-intercept on the graph. It's there. And then we always want to start with that because that's a point. That's really all you put on graphs. The slope is not a point. It just gives us directions to get from one point to another point. And so we're starting with putting the y-intercept on there, and then the slope will give us directions. And the denominator tells us how far to go in the x direction. The numerator tells us how far to go in the y direction. And I want to make sure you understand those aren't variables I'm adding there. That's just a little mental note to tell you guys we're going to count the 2 in the x direction and the negative 3 in the y direction. So I'm going to do my little green tracers again. So from my y-intercept, I'm going to go right 2, and then I will go down 3. And then that'll give me the placement of a second point. Now I want to do a third point, but I want to talk about the slope here a little bit. So what's going on with our slope is it is negative, the whole fraction is negative 3/2. What that means is that that could equal negative 3/2, or that could equal 3/-2. For the overall fraction, to simplify as a negative, either the numerator would be negative or the denominator would be negative. And so if we think about it in that way, we could also count our slope off going in the other direction, where we apply a negative in the x direction and a positive in the y direction. And so doing that, I would go to the left 2 and I would go up 3. And put a point there, and you can see that still lines up with the other points, counting off in that other direction. So that's how the signs work out with the numbers, and also makes sense on the graph. So we can then connect those points, go past them and draw arrows. And you have the line. I'll go ahead and erase these green marks here. So we have a clean graph. So that's the idea of graphing using the slope and intercept slope-intercept form. You can also still graph lines using the just generating 2 ordered pairs like we did before. Really understanding the slope-intercept form of a line is really handy for the modeling work with lines that we're going to be going into. Some people prefer it for graphing, other people prefer just generating ordered pairs for graphing, but with the modeling it's very helpful in understanding the behavior of the line when it's wrapped in real-world context. But anyway, go ahead and give some of these a try and see how you fare.